Welcome everyone. I'm Alex Pascalis. I'm a technical officer here at the Energy Institute, working mostly in human performance. I'll be hosting the webinar today. These webinars are organized by the Energy Institute and are part of the Technical and Innovation webinar series. I believe this is the first of the year, and it's about integrating human factors into the risk assessment process. This is off the back of our newly released publication, EI 3579, Guidance on Human Factors in Task-Based Risk Assessment, which you can access for free on our EI publications website. First, I'm just going to run through some of the webinar housekeeping. So as you can see on the slide, this webinar has been recorded and the recording will be made available after the event. All the participants will be muted except for the presenters. If you have any questions during the webinar, please post them using the Q&A function that should be at the bottom of your screen. Please don't put the questions in the chat, but do feel free to introduce yourselves in there if you want to put your names and companies, what you do. So the Energy Institute is the chartered professional membership body for people working across the world of energy, and our purpose or goal is to create a better energy future for our members and society by accelerating a just global energy transition to net zero, which we do in the following 3 ways: developing the future energy workforce, bringing together expertise and advice, and enabling lower carbon energy. This leads us on to our technical and innovation work program. So our technical and innovation work program covers 3 overlapping areas: the energy transition, health, safety and environment, and fuel quality and management. As you can see, we have many committees in these areas, and our publications are developed through these committees. So just to let you all know, the EI's flagship conference, International Energy Week, will be taking place from the 25th to the 27th of February in London, which is in about 2 weeks. The focus of the conference will be how we're navigating the world's energy transitions. If you'd like to attend, you can go to that link that you can see on the slide, www.ieweek.co.uk. Secretary John Kerry will be there to receive this year's EI President's Award, which is exciting for us. So yeah, now let me introduce the authors of the guidance on human factors in task-based risk assessment. Dr. Marcin Nazaruk is a psychologist with over 12 years of experience at organizations such as BP, Baker Hughes, SSE, and he's now the founder and CEO of Psychology Applied. Piotr Chikowicz is an engineer with over 4 years of experience at Baker Hughes, where he was the HSE lead of Continental Europe North, and his current role is head of operations at Psychology Applied. I'll hand over to Dr. Nazaruk now, who will present for about 30 minutes before we go into a Q&A session to close out the webinar later. So as I mentioned, if you have any questions during this webinar, put them in the Q&A function and hopefully we can answer them later on.
Excellent. Thank you so very much, Alexandros, and a very warm welcome. It's fantastic to have you here. I think you need to stop sharing, Alex, so I can...
I'll hand over to you now.
All righty, and we'll start. Excellent. And so let's start. So a couple of years ago, there was a very sad incident. The worker or 2 workers needed to work on this specific valve. The risk assessment was in place. And on the day, they've approached a wrong valve, started working on it. Unfortunately, that led to the release of steam, and both died in that incident. Despite having the risk assessment in place and hazards being controlled. And this case went to the court, and the judge emphasized that the company should have foreseen and prevented the risk of the workers approaching the wrong valve. And this sad story takes us to a very important point, that identifying and controlling hazards is not enough to effectively reduce the risk in operations. And today, we'll cover the difference between hazards and error traps, how to add error traps to the risk assessment form, the skills needed for the front line to improve hazard identification and risk perception, common challenges based from what we see from our practice of implementing that in large organizations. And we'll also show you a number of examples and case studies of how this works in practice. So before we go any further, I would like to also clarify an important point. In the UK, there is a COMA regulation in place that requires human factors analysis through the safety critical task analysis, and this guidance does not fulfill the UK's regulatory requirements for managing the human factors on COMA installations. However, we've recognized that most risk assessments are task level and they're conducted as part of the job planning. That COMA is a UK-based regulations, and globally, many, maybe majority of organizations do not refer to it. The safety critical task analysis covers only major accident hazard scenarios and not necessarily personal safety risks or dynamic risk assessments. And this new guidance helps companies to enhance a very, very popular and common method that is risk assessment in the form of job safety analysis. There are different names for it, whether that's work permit processes, job briefings, and work. And it is not a replacement for safety critical task analysis, but it is a practical tool to help manage risks associated with human factors. And so my name is Dr. Marcin Nazaruk, and I've spent majority of my career working in high-risk industries, predominantly in the energy sector. However, I've spent also a lot of time in other industries, whether that's heavy manufacturing, food manufacturing, pharmaceuticals, a little bit of nuclear, a little bit of aviation. And as part of my journey, I was very privileged to be able to take science and apply it in practice to add value and deliver innovation. And my work, I was very privileged to be able to write or co-write a number of industry guidance documents for different organizations in the energy sector, whether that's on incident investigations, learning from normal work, or this one we'll talk about today, human factors in risk assessment. And today, I'm joined by Peter. Peter, please say a few words about yourself.
Sure, thank you, Marcin. So my name is Peter. I started my career as a drilling engineer. I was working on oil rigs and dealing with realities of the job. And early on, I noticed that something is not correct with our risk assessment. So our risk assessment looks solid on paper, but in practice, we still had incidents, we still had near misses, and work often didn't go as planned. And I couldn't name it back then, but I knew that just identifying and controlling hazards is not enough to reduce the risk. So over the years, I developed a keen eye for spotting these gaps. So procedures that didn't match reality, training that missed the mark, work environment that make errors more likely. And my engineering background pushed me to think systemically, why do these mistakes still happening? Why in the work setup, processes, equipment, what's driving those mistakes? Why do people have to constantly adjust and adapt to get the job done safely and efficiently? And now we have a name for this, and we call this error-producing conditions. And once we start recognizing them, we can design systems that actually help people work safely instead of just advising them to stay focused or pay attention. And that's why I co-authored the guide on human factors in risk assessment with Marcin. and bringing together everything I've learned on the front line from my frontline experience on the rig sites to my engineering mindset. And because I think that at the end, what really matters is not just assessing the risk, but actually reducing the risk. So very welcome, everyone, and happy to be here. Back to Marcin. Thank you.
Fantastic. Thank you so much, Peter, for all the help and your expertise that helped to help us to deliver the guidance. A few words about the company Psychology Applied. We help large companies to modernize safety practices based on human performance, human factors, and safety too. We work with leaders and help to upskill safety professionals. We redesign the major processes, investigations, proactive learning, behavioral observations, accountability, and one of those areas is risk assessment. And we are very grateful for being selected to write the guidance by the Energy Institute, and we could utilize our experience of doing that and share those experiences from practical application into the guidance. And the guidance is focused on two major parts, two major sections. One is the risk assessments that happens during the planning phase. So this is where we have the risk assessment form, and we identify systemically hazards and controls and so on. And the second chunk is the that we added. The second section is risk assessment that is more dynamic. So that happens just before, during, and after, both risk assessment and management from the dynamic perspective. And so we'll cover those sections separately, and we'll start with looking into the risk assessment as a pre-planned effort. And so to start, we need to first align what is the difference between hazards and error traps. In the guidance, you will see the term error-producing conditions. I use the term error traps when we work globally. That term is perhaps more common in the companies that we work with, but we mean the same thing. Other terms that you may come across is performance-shaping factors, performance-influencing factors. They all pretty much refer to the same thing. And so let's start with hazards. Hazards can be defined as anything with the potential to cause harm. And here we built on the research that looked into so-called hazards as energy. There is a school of thought based on the scientific research showing that injury happens when the amount of force or energy that the person is exposed to is bigger, there is more of it compared to what our body can withstand. We interface with energies all the time, with forces all the time, every time we interact with physical objects or substances, and it's the amount of that force or energy that cause harm. There is I won't go into detail. That's a world in itself. It can be calculated into kilojoules, but practically speaking, there is this list of 10 energies that are served or are used as a set of keywords to help identify those sources of energies. And these energies, the research shows that using those keywords increases the number of identified hazards between 30 to 50%. So it's a very effective way of identifying more hazards compared to when we don't use that list. And then we can compare that with error traps or error-producing conditions. Those are the things that increase the likelihood of error. Yes, they also can reduce the likelihood of error. That's fine. Here, again, I'll keep it simple. And so those can be the procedure that is out of date, the training that didn't cover the skills that were needed, or the tools that were not available, or the equipment that is confusing. We'll show you a number of examples. And then people need to deal with these challenges when they do the work, and so they do so through those conditions can lead to error, or they may lead to adaptation. So for example, if the procedure is unworkable, workers can develop their own procedure. Or if the tools are not helping, or there is not the right type of tool, they may fabricate their own tools, and sometimes those adaptations are unhelpfully labeled using judgmental language. But it is a form of dealing with those conditions that make the work difficult. And so now let's start with a simple example. So you see those two cans, and one is a cooking spray and one is a lubricant. Now imagine you are cooking a dinner for your family, and these two cans stand next to your cooking hob, and let's try to now analyze the risk. So if we think of a hazard, so what would be the hazard here? If we think of something with the potential to cause harm, what is causing the harm? It's it would be the lubricant chemical if ingested. Then that could be the hazard. Now, what could be the potential error in our scenario? The error being, oops, I didn't mean that, would be a person takes and uses the lubricant spray for cooking. And then what would be the error traps or error producing conditions? So conditions that produce or create error. Here in our case, that would be spray bottles that look very similar. That visual similarity is a factor that significantly increases the likelihood of error. And this design consists of color, font, logo, black line, positioning, etc. So this is a simple everyday example. Now let's have a look at the industrial example. This is an illustration based on a photograph. Here you see a worker operating a control panel. And again, we can ask, what are the hazards? And we could see electrocution, hand entrapment, burn, hearing damage, potentially pressure release. Okay. But when we then ask, but what increases the likelihood of this worker making a mistake and pressing a wrong button? We'll see that the pipes are in the way, and they constrain the movement, and they reduce the visibility. And the color of the buttons, mainly red and green, if this person has medical condition of color blindness, they will not see the difference between those. And it's middle of the night, and this should be a two-person job, but their colleague was called to a different job, and the work instruction does not actually cover how this should be done, and the radio to the control room is broken. So we see those different conditions we see on the right-hand side. They're difficult it's difficult to classify them as hazards, because on its own, they do not have the potential to cause harm in the same way as the hazards, as the energies do. And yet, you probably see how they increase the likelihood of failure. And so now what we can do, and that's opportunity that our guidance brings, is to learn how to identify those conditions before they lead to or contribute to a problem or an incident. And when we look at the risk assessment process, in the UK, there is a foundational process called 5 steps to risk assessment, which is identify hazards, then assess the risk, control the hazards, record, and review. And that's good. And that works well for hazards. But we need to expand that to now focus on identifying those error-producing conditions and the potential errors, and then give some thought to how we can address those and control the risk associated with that. And so now, while we can identify hazards, just looking at the exploring the workplace and the work and looking, oh, here we've got electricity, here we've got something else. it's very difficult to do that for human error or non-compliance or human action, because the potential risk is associated with a step. So people doing something and interacting with something, interacting with this control panel, with this lever, with reading this gauge. And so here, overall, trying to talk about errors generically is not very effective. It's much more effective to do that focusing on specific steps. And so here, now we can identify the steps, and then for each step, we can explore the hazards or potential forces and energies and the potential error traps and error producing conditions that may lead to or that may create error or non-compliance. And so let me show you some examples. So here we've got a task of emptying a chemical tank. And step 3, so here we've got an extract. Step 3 is to close the valves and disconnect the hose, and the hazards are chemical leak and burns. And this is based on the real risk assessment, and the controls were forklift training, it was training, chemical awareness, and a spill response procedure. But now when we added the 2 columns, you see, so the error traps and the error traps controls, and we engage with the technician doing this work about what makes this work difficult, we've learned from them that they may disconnect the hose before closing the valve. So this is the potential error. And why is that? Because there was no visual indication if the valve is closed or open. And technician may think the valve was closed while in fact it was open, and that could lead to a spill. And with that insight, then we could think about how we could prevent this error. And in this case, that company decided to redesign this connection to make it impossible to disconnect the hose with the valve being open, plus added the visual indication if the valve is open or closed. But that to redesign and adding the engineering solution eliminated the risk of the error and mistakenly disconnecting the hose with the open valve. But what you see is important here is this insight, this aspect of risk was not visible to those who did the risk assessment before. And therefore, that means that the risk profile and the calculation of the likelihood that was conducted also did not reflect the actual risk. The actual risk was higher than the team believed because they did not see those aspects of risk related to error traps. Here is another example. So working on an electric panel. And here the step is to identify which circuits the person should work on. And the potential hazard is electricity leading to shock, burn, or arc flash. And when we look into the error traps and ask the person what makes identifying the circuits difficult, we've learned that the labels on the circuit are faded off and were not readable. And so that increases the risk. And then the in addition to the popular controls that you would expect, we were able also to minimize the risk associated with that error by both replacing the labels, using the material that doesn't wear off in these conditions, and then also color matching the circuits on the plant with the circuits on the drawing. And again, for the risk assessment that focused only on hazards, the risk that was associated with the error traps in place was not visible, and therefore that led to a belief that the risk is lower than it actually was. So here we talked about some examples of the integration with the process. Now let's have a quick look at some tools for the front line. And here we've got I'll show you some examples of tools that can be used before, during, and after the work is done. So first, before, we can engage workers into exploring what are the error traps and potential hazards. So here you see the wheels, my original wheel, and the adaptation done by the Energy Institute, as well as we've got the last minute risk assessment with questions checking if there are any conditions that increase the risk. Then during the activity, so we've got a number of techniques which have been tested in various industries. And so one is so-called 15-second scan. This is based on the research on how our vision works, how our attention works, and showing that when we scan the area around us in a systematic manner through a pattern, for example, horizontally, we are more effective to capture potential sources of danger. And this technique is, for example, used in pilot training. So when pilots learn how to fly, they learn how to systematically scan both the what's around them outside of the plane, but also go through systematically through the different gauges. And I've experienced that as my pilot training as well, and it was very, very helpful. The next technique is so-called look, point, and call out. That technique has been tested and popularized, for example, in Japanese among the Japanese train drivers to reduce the risk of crossing on the red signal. And here it is a way of pointing attention and focusing the cone of attention on a specific point, and then verbalization helps to activate some cognitive processes that help to reduce the likelihood of error. And I often use that even when I fuel my car. So to prevent the mix-up of the gasoline and diesel, I say, okay, this is diesel, point to the car, diesel, and then that give me that additional confirmation. It is a behavioral technique for self-management for error reduction. And there are some other techniques like self-check, peer check, and we added also criteria for stopping the job. Those are behavioral techniques based on the skill. So what is important to emphasize, it's if anyone wants to use it, is not as simple as just ask people, oh, just do the 50-second scan. This actually skill that needs to be practiced and developed into a habit to work effectively. And then we've got the after. So after we've got an independent verification, meaning there is someone else who didn't do the job itself, comes to the area and verifies that everything is okay. And we've got a post-job debrief. And these are a number of questions inspired by the operational learning from normal work, where people can reflect on what could be improved, what were the surprises, what were the weak signals and things that made the work difficult but did not result in any problem or an incident, and that would allow for capturing those issues in a proactive manner, building on the worker's experience from the job. And so now let me show you some examples of the practical implementation. And let me start with some challenges that you are very likely to face. And we see that in, I think, all organizations we work with, every single one. And so when we try, or where companies try to implement this, here are some common challenges. Number one is confusing error traps and hazards. Very common. Again, this is a skill. Building clarity on what's the difference between the two is important to drive the quality of the output. Another very common one, using behaviors as error traps, like selecting a wrong tool, pushing a wrong button, or advice like keeping hands away from pinch points. Another very common one, using cognitive states as error traps, not being aware, not knowing, underestimating, or some labels like overconfidence and complacency. Those are not that helpful. Yes, the cognition, so how our mind and attention works absolutely is a factor. But in practice, two things happen. One is the fundamental attribution error, which is the cognitive bias and over tendency to point to the person as a problem and explain the behavior by referring to the personal characteristics. And that is a bias that affects the majority of population, and we see that every time. The second is what you look for is what you find. So this is a phenomenon that shows that people find information that confirm their pre-existing mental model. So if the mental model is that complacency is a problem, this is what will be coming up. And so, I've studied a lot of cognitive and behavioral psychology. That's fine. In practice, we need to help people to differentiate and go beyond that. Because if we say not being aware or not knowing, that's not good enough. We need to ask what is responsible for giving people awareness or giving people knowledge in the workplace, because in organizations we don't work just with random people from the street, right? And so if they don't have knowledge or awareness that they should have, that's not necessarily on them, but there is something in the organization that should have provided that. And we can ask, what is it? Because otherwise, if we just end with not knowing or not being aware or those other cognitive states, then we gravitate towards solutions like remind, refresh, run a campaign, posters, etc., which are not helpful and not that effective actually to reduce the risk. And then we've got the challenges how to build the skills of doing this well among the safety team, operations, and frontline employees. The problem that what you look for is what you find, being that you can give the updated template to people and they will tweak it in a way to confirm what they already know. So if they're not prepared, they will use the new template to just give you more of the same. And the question is who will coach and ensure the quality of the output and how to achieve the common understanding and common of this topic and the common use of the terminology. Now, when we work with the frontline employees and helping them to improve their hazard identification skills, we see three levels of quality when it comes to hazard identification. One is using only guide word. So this is the guide words from the energies that you've seen, like gravity, like electricity. The next level is when they translate it into some generic risk, like gravity into dropped object. That's better, but that's not good enough. What we want is the hazards to be described in a contextual manner. So, for example, when we put the pallet on the top shelf, the lighting is poor and the driver can push the pallet too far and it could fall. So this is a desired, detailed way of describing hazard that connects the potential danger with the activity and some additional conditions that exist in that work environment. And so what we see overall is that when we give people a list of energies, the number of hazards through energies increases, but does not automatically improve that quality level 3. And so getting from level 1 to 3 requires practice and repetition and coaching to get it right. And so to help workers to and enable them to identify more of the hazards and error traps, what we do is this training session that goes through the hazard identification skills, how to identify error traps, how to differentiate between them, how to identify critical steps, some of those skills that I showed you, and also we look into the dynamic assessment of risk. So this is how to increase sensitivity to the potential changes and how they can develop into danger and how we can predict movement and what can collide with what and how to scan the area around them and how to predict, in quotes, of course, because there is no prediction in the ultimate sense that I will know, but you try to identify where the likelihood is. And then, of course, they go back to the workplace and that those skills needs to be practiced and reinforced with the help of team leaders on an ongoing basis. And when we tested the effectiveness and we did a before and after, we saw that this increases the number of identified hazards by 50%, also improves the quality. So moving from level 1 to level 3, and then also enables to identify error traps, because this is a new term. Workers don't know about it, so we move from 0 to 5 on average per scenario, and the same, the quality improves. And so now this is the enablement of the front line. And now let's spend a few moments about the implementation at the organizational level. So first of all, it's worth highlighting that risk assessment or risk management is an ecosystem of different components that needs to be aligned together. So we've got the policy or procedure. We've got from the stems the template that enable people to comply with the policy. Then we've got training that enables the provide skills to use those templates to be compliant with the policy. We have coaching, data analysis, KPIs. Those can be those different elements. And so now, if you think about identifying error traps, some of them, like design, may be in place all the time. Others, like radio to the control room not working, or one person being off work or on a different job, those are temporary and they change. But with that change, also the risk profile changes as well. And the question is, how can we identify those temporary aspects that affect the risk? And so now imagine now that your team identified a new hazard or an error trap before the job starts or during the job starts. And the question is, now what? What happens with that information? So where is it recorded? Who records it? Who receives it after recording it? Who validates it? Who then decides what to do with it? What action is taken? Who provides the resources? If we need to buy a new tool or rewrite a procedure, how is this information used to reduce the risk, and how to provide feedback to the workers so that they are not left with an impression that they reported something and nothing has been done? And how is this information shared more broadly? So those are the questions that are important to consider when discussing how to deploy this upgrade in an organization. And here is a case study showing how one major global organization implemented that process. So first, it started with the awareness of error traps. So just to build that common understanding and common language around what it is, how it works, what's the difference between this and hazards. Then we went to one of the sites and did a proof of concept. So we did this, we redid an existing risk assessment, and were able to identify the error traps in addition to hazards. We also demonstrated that the error traps that we've identified proactively, where there was no accident, also were the same conditions that they found in an incident about a year earlier on a similar task on a different facility, but similar task, similar equipment. So then with that case study, photos and stories, we were able to go back to the stakeholders and explain, demonstrate the value. And then the pilot proceeded. So here the one site was selected, and there was training for the HSC team and the ops team, and implementation support. That resulted in more examples, more case studies, more demonstration of value. And then we also supported that with the competency pathway for the HSC and quality and operations. Because here the question is, who will do this and who will help to ensure the quality, who will provide the ongoing support in the implementation? So those people in that organization were called champions, and so they used our competency pathway to to get upskilled on these topics. And then the process-related and policy changes followed. So this is where we updated the risk assessment procedure templates, training, library of examples, and the rollout then moved to other sites. It was cascaded down through a waterfall type of approach, and it progressed and achieved full integration with multiple wonderful examples showing that the risk that was identified and assessed in the original risk assessment was actually higher than they thought, because they were now able to identify new conditions that were not identified as part of the original risk assessment and hazard identification. And so with that, thank you so very much for your attention, and I'd love to hear your questions.
Okay. So I'm not sure where Alex has gone, so I'll jump in here. Hi everyone, Stuart King here from the Energy Institute, practice manager for the human performance area. Oh, sorry, Alex is there. I didn't see you.
Yeah, I just had a quick technical issue. Yeah, we did get a few questions actually. So I guess I'll just read them out and then see if we can answer them. So our first question was, how can we define unforeseen risk?
How can we define an unforeseen risk? Okay, the reason I'm hesitating with the answer is that I feel that this question takes us to very conceptual conversation and theoretical conversation, and that's fine. I think there is place for that. Now, what I would say is, where I would perhaps reframe it is that when I go to a job and I then talk to the people who have so-called tacit knowledge, so the hidden knowledge about the task and what works and what doesn't work and what makes the work difficult and what is frustrating and what they need but don't have, I get insight in a very practical ways about the challenges and factors that affect the risk that I would not be able to find otherwise. Now, is that capture the entirety of undefined risk? I'm not sure. But also, my priority here is to help and add value and reduce the risk. And I feel that I can do it well by capturing the wisdom of the workforce when nothing goes wrong. And here, and I'm hesitating to start speculating and starting the conceptual discussion about the nature of risks and the definition of that. So here, I'm sorry, I didn't answer your question directly. I get that. But also I want to reframe it and focus on the fact that we very practically can improve the effectiveness of our approach to identifying factors that affect the risk in the workplace.
Thanks, Marcin. I just realized I did skip over one question that was, will the presentation be available to download? So this recording, the webinar recording, will be sent emailed to all of you in about a week or two. But as for the slides, I'm not sure if that's something, Marcin, would you be happy to share your presentation? Would we be able to send that out?
We'll take that offline.
Okay, sure. Okay, and then we had another question. When we try to recommend control for hazards, we have hierarchy of control that can be used as a guide to write the priority of control. Do you have a guide when writing the control for error traps that can help us assess the effectiveness versus the difficulty of the recommended control?
I can take
Yes.
that, Marcin.
Go on. Go ahead.
Yeah, so actually in the guide in point 3.4, we have stage 4 control hazards, risk and error traps for each step. And in this particular section, you will find a table when we are comparing hazards and error producing conditions controls against hierarchy, right? So starting from the elimination and PP, that goes for hazards. And for error traps, there is also another column when you can see examples of controls. So you can refer directly to that.
Excellent. So there is a guidance inside the document on that. A great point.
Great, thank you. Okay, another question on, can you compare error traps to escalation factors in a bow tie risk assessment?
Yes. So there will be an overlap. Some factors will be present in both. And here, my experience with the bow ties and the degradation factors is that they touch on similar topics. I find what we added in the guidance is perhaps broader and more comprehensive. Also, we recognize that the bow tie is a different methodology that is triggered by different elements, is done under different circumstances by different people, perhaps compared to the task level risk assessment. So there will be similarity here with the guide. You've got a toolkit that you can give the frontline and the HSE teams who are involved in the task level risk assessment.
I can add on that also, Marcin, that on a very basic level, I think that escalation factors refers to barriers, right? And error traps are related to errors. So escalation factors reducing the effectiveness of barriers versus error traps are leading to mistakes that are more likely to happen. So those might be different, those might be similar in some cases. However, error traps relates to human error, not to the barrier, right? So we are not talking about controls when we are speaking about error traps.
Thanks, Peter.
Thank you. Hi, Marcin. Curious to know how you evaluated the improvement in hazard/risk identification to demonstrate to an organization the impact of including human factors considerations into the process. Was it more of a qualitative assessment or more of a structured experiment?
It was a structured experiment. We did a before and after case study. So we used multiple scenarios with different teams. And before we started the training, we gave them the scenarios and asked them to identify as many hazards and error traps that they could. And then we did the same after the training. And so the numbers I showed you come from that study, which very nicely showed the quantitative difference in both the number, but also the quality, referring to the 3 levels that we've seen.
Thank you. For new people to relate to the concept of error traps against hazards, could these be seen as those situations that could lead to the release of certain risks? For example, if I do not identify the correct valve, I release the risk of being hit by steam.
As those situations that could lead to the release of certain risk. So yes. So I think that, so if you take the visual similarity of valves as a scenario, right? Inside, you've got the pressure or steam. And so here, the visual similarity is not on its own a source of harm in the same way as exposure to pressured steam is, but definitely is a factor that increases the risk of action, so error, opening a wrong valve, which then leads to a release of energy. So definitely. Now I would just perhaps start with the word the situation. I would differentiate the situation from those conditions. So situation would be, as I see it, all-encompassing. So in the situation, I've got a job, I've got a goal, I've got my constraints, I've got time, colleagues, tools, etc. Right? And part of that situation is also visual similarity. And now that condition of visual similarity is something that increases the likelihood of opening a wrong valve. So I think it's close. But now those differentiations really matter to get a good output, because if we confuse hazards and error traps, we tend to not get value out of it, and we get more of the same. So to get a new quality and good insight, we need to meaningfully differentiate between those categories.
Thank you. So we've got a question from Denise. When you piloted new instructions, how did you measure the success that the process/procedure was actually followed and understood, especially with such a qualitative task as opposed to an easily measured quantitative task?
Okay, so on the compliance, when we introduced the new policy with the updated risk assessment, so that was based on the qualitative. So we were able to get feedback from the champions and those people who were responsible for the local deployment. We could get feedback on how this works, what's useful, what may need to be tweaked, and so that that qualitative feedback was used to refine the document in our case. And of course, you could go into different levels of depth with the evaluation and assessment if you wanted to. In our case, that was deemed to be sufficient for what the company needed at the time.
Thanks. Question from Daryl. How long did it take to fully implement the program on the last case study?
Okay. So 12 to 18 months. So the initial phase. So the early phases of building common understanding and building the business case, a few months there. Of course, not full time, right? This is just between meetings, planning and making it happen and getting the green light. Then another few months for the first pilot. In parallel, this upskilling of the HSC function, and then about after 8-10 months, the first phase of the scaled deployment started happening. And then, given that they had over, I think, 200 sites globally, the full circle lasts over 18 months. And in a way, still ongoing, because there is, like, with thousands of risk assessments, you don't do them all in one go. There is process to it, and to revisit those in a systematic manner when it's time for a refresher and so on. So, but initial was about 18 months.
Thank you. Okay, we've got one. How can you build capacity to implement this on ships with multinational crew?
Okay, so welcome shipping. Wonderful to have you. Okay, so I'm hearing a couple challenges in that one question. So one is on the ships, which means remote type of work, and multinational crews, which also hint at the language and common understanding and common practices. I think there are two ways of doing it. So either onshore, when they are when they're in port, to go through that training and practice and to reinforce that. And then when they go back to the ship, ensure that they apply those skills, or work remotely. Some of it could be done through the e-learning, and maybe remote coaching. I think there now technology allows for doing that. Either way, it is a skill that needs to be practiced and reinforced and refined over time, and it works better if it's integrated with the process for risk management.
Thanks. How is this seen by leaders that are deeply convinced their operations are already safe? I find that the biggest challenge is in the leadership and not on making this move forward. Do you have any suggestions based on your experience?
Peter, what's your take on that?
Well, I think that the classic example is the BP Macondo disaster, right? So when they were actually the day of the catastrophe, they were celebrating, I believe it was 7 years without major accident or something like that. And couple hours later, these things happened. And yeah, it was one of the biggest environmental disaster, and people died as well, if I'm not mistaken. So lack of accident is not always a good indicator that you are safe. So that is my take on this.
And I would just add that in practice, we are able to demonstrate through photos and case studies that the existing risk is actually higher than they believed. We could also, many times, we could also correlate, or the error traps we found in a proactive way, we could show that these are the same things that they found in incident investigations in previous incidents. And now that takes us to the building a business case, because if you now wait for an incident to find those error traps, your costs are incomparably higher compared to the cost of finding it out in a proactive way. And this helps, but also what we find is that working with the leadership teams to help to shift their mindset more towards proactive, and the recognizing that failure and success have the same underpinnings, have the same causes, people adapting to operational constraints, and that shift in the mindset helps to overcome that perception that if we don't have accidents, everything is fine. So those two, the mindset plus the demonstration and business case, tend to help.
And I can add on that as well that when we are identifying error traps lead to mistakes, but the consequences are not always related to safety. So if they are hesitant about safety because they think that they are safe, there are concerns about productivity, efficiency, quality. So mistakes not always lead to some kind of injuries, harm to people, but can also lead to delays and other type of losses. So that might be another factor to consider for the management team to invest in shifting the risk assessment process.